Many embedded applications such as meters, sensor nodes, and data loggers need memory with high endurance to store data at regular intervals. EEPROM, offering a high endurance value of up to 1 million read-write cycles, is an ideal memory choice to store such data. But not all MCUs come with on-chip data EEPROM, and even if they do, they may not offer the necessary size or peripherals required for your application, and an external EEPROM may not always be an option. In this video, we will show you how you can easily emulate data EEPROM using the on-chip flash memory available on PIC24 MCUs and dsPIC33 DSCs using MPLAB code configurator. Before going into the MCC library details, let's take a quick look at the basic differences between EEPROM and flash. EEPROM typically offers high endurance of up to 1 million erase-write cycles, whereas flash offers up to 10 or 20,000 erase-write cycles. The on-chip EEPROM size in an MCU is usually very small, whereas MCUs offer a wide range of flash memory options. Microchip's PIC24F MCUs and dsPIC33 DSCs offer up to 1 megabyte of on-chip flash. Wear leveling is not required in EEPROM, as they already have high endurance. With flash, you may need to implement a wear leveling algorithm to increase the endurance, which in turn increases the software complexity. To select an ideal MCU that meets your application's requirements from a wide range of flash MCUs while still being able to address the limitations of not having the on-chip EEPROM, the Data EEPROM Emulation Library in MCC simplifies EEPROM emulation using on-chip flash. You can configure the Data EEPROM library for a PIC24 MCU or a dsPIC33 DSC using MCC in just a couple of minutes. The library has a small memory footprint to emulate EEPROM even on an MCU with small on-chip flash. The library completely abstracts wear-level complexities, and it's very simple to use with only 3 APIs to be called from your application. Understanding the endurance requirement in an application can be helpful. Taking the example of a typical energy meter, we may need to store 2 variables, active and reactive energy. These may need a total of 16 bytes. If we need to update these variables every 45 seconds, and assuming the meter life to be 15 years, the required endurance will be 10.5 million erase-write cycles. Now that we know the desired endurance, let's determine the required flash size for the emulation. As per the Data EEPROM emulation algorithm implemented in the MCC library, total effective endurance is derived using the shown equation. In this equation, the page size is the minimum amount of flash memory affected by the erase operation. This is typically 512 words per flash page. Page status size is the size of the first location of each flash page used for storing the status information, which is 1 word. Data EEPROM bank size is the number of unique addresses that can be stored on a flash page. The maximum allowed bank size is 255. If we want to store 300 variables or addresses, then we need 2 banks, where the addresses will be equally distributed between them. As per the algorithm, the number of pages required will be 2.089. So, we need 3 pages of physical flash to achieve the desired endurance. Given that each page is 512 words, with each word being 3 bytes, we need 4,608 bytes of flash in order to emulate the EEPROM with the desired endurance. Let's go through a quick demo to understand how to configure the EEPROM emulation library in MCC. In MCC, open the 16-bit Data EEPROM emulation library under the Project Resource menu. Here are the default values for this project. The requested number for the EEPROM address is 255. The requested total effective endurance is 10 million. If you want to use a specific start address, you can disable the highest flash memory area and then manually enter the flash address. Here is the total effective endurance calculated based on the values we entered. As you can see, the total number of EEPROM banks is 1, and the number of flash pages per EEPROM bank is 2. The data EEPROM size per bank is 255. The following are the device parameters. The flash endurance is 10K cycles. The flash erase page size is 1024, and the flash supports ECC. Now, suppose the requested number of EEPROM addresses is increased to, let's say, 300. You will then see the total effective endurance has changed to 72 million. This is because the number of EEPROM banks has increased from 1 to 2, and each bank can save 150 words each. Now, let's do a clean build. As we look into the header files generated by the MCC library, we can see that the d.h header files contain all the necessary APIs required to initialize and to read and write the data flash. Once the MCC Data EEPROM Emulation library is initialized, simply call the following 3 APIs in your application while the library takes care of the where leveling complexities. d_int will initialize your emulation library. d_read will read back the data from a particular memory location. And the d_write function will write the data to a particular memory location. As you can see in just a few simple steps, MCC allows you to emulate the data EEPROM using the on-chip flash and achieve the required endurance. The library has a small memory footprint of 6K bytes and works even on MCUs offering small flash memory. With the flexibility of EEPROM emulation on any PIC24 MCU and dsPIC33 DSC, you can easily select a device that meets your application requirements. For more information on the Data EEPROM Emulation Library implementation, you can refer to the app note AN1095, Emulating Data EEPROM for PIC24 Microcontrollers and dsPIC Digital Signal Controller. To learn even more, visit microchip.com/DEE-PIC24-dsPIC33 and download the library along with the associated documentation. Thanks for watching.